Welcome to this rigorous scientific lecture on using artificial intelligence to validate startup ideas through fast, systematic experiments. Today we'll explore a structured weekly loop that combines hypothesis testing, metrics, and pivot rules to minimize time to product-market fit. Let's start with a fundamental question. Why do startups fail? According to CB Insights, approximately 90% of startups fail. The number one reason, cited by 42% of failed startups, is no market need. This is a validation problem, not an execution problem. 90% failure rate. The largest segment, 42%, fails because they built something nobody wanted. This is the critical problem we're addressing today with AI-assisted validation. Traditional validation methods involve building a minimum viable product, launching it, gathering feedback, and iterating. This process typically takes 3 to 6 months minimum, and often much longer. AI fundamentally changes this timeline. Using large language models, synthetic data generation, and automated testing frameworks, we can compress validation cycles from months down to days or weeks. Let me ask you a question. What is the scientific method? It's a systematic approach to knowledge acquisition involving observation, hypothesis formation, experimentation, and conclusion. We're going to apply this exact framework to startup validation. The scientific method forms a loop. Observe a problem, form a hypothesis, test it experimentally, draw conclusions, and feed those conclusions back into new observations. This is our startup validation loop. Now let me introduce the core framework, the weekly validation loop. This is a 7-day cycle designed to test one hypothesis, measure one primary metric, and make a binary decision: continue or pivot. Days 1 and 2 are dedicated to hypothesis formation. You use AI to analyze market data, competitor intelligence, and customer pain points to formulate a testable hypothesis about your startup idea. Days 3 through 5 involve designing and executing your experiment. This could be a landing page test, a synthetic customer interview using AI, or a micro-product prototype. Days 6 and 7 are for rigorous data analysis and making the pivot decision. You calculate your key metric, compare it against your success threshold, and decide whether to continue or pivot. Let's dive deep into the first component, the hypothesis. A good startup hypothesis must be specific, measurable, and falsifiable. Let me give you an example. Here's a bad hypothesis. People need better productivity tools. Why is this bad? It's vague, unmeasurable, and unfalsifiable. You can't design an experiment around this. Here's a good hypothesis. Remote software engineers aged 25 to 35 will pay $20 per month for an AI code review tool that reduces pull request review time by 50%. Notice the specificity: target customer, price point, value proposition, and quantified benefit. How do we use AI to generate these hypotheses? Let me walk through a concrete process using large language models. You input 3 data sources into a large language model: market data from industry reports, customer pain points from forums and interviews, and competitor analysis. The AI synthesizes these inputs and generates multiple testable hypotheses. Here's a concrete prompt. Given this market data showing the developer tools industry is growing at 15% annually, these pain points from Stack Overflow, where developers complain about slow code review cycles, and these competitors offering manual code review services, generate 5 specific hypotheses for AI-powered developer tools with target customer segments, price points, and value propositions. The AI doesn't just output random ideas. Modern LLMs can provide confidence scores based on data density, market size estimates, and competitive landscape analysis. You select the hypothesis with the highest confidence score that aligns with your capabilities. Now let's move to component 2, the test. The test is your experiment design. It must be fast, cheap, and directly measure the hypothesis. Let me ask you, what makes a good startup test? Is it building a full product? Is it conducting surveys? Let me answer this scientifically. A good test reveals actual customer behavior, not stated opinions. Surveys tell you what people think they would do. Behavioral tests show you what they actually do. There's a massive gap between these two. In science, we have a hierarchy of evidence. The same applies to startup validation. Let me show you the hierarchy from weakest to strongest evidence. At the bottom, weakest evidence, surveys and opinions. Next level, interviews with hypothetical questions. Middle tier, landing pages with email signups. Higher tier, pre-orders or waitlist requiring payment. Strongest evidence, actual purchases and product usage. Your goal in the weekly validation loop is to reach the highest tier of evidence possible within 7 days. This often means using AI to rapidly prototype something that appears real enough to trigger actual behavioral commitment. Here's where AI becomes transformative. Let me give you specific examples of how AI accelerates testing. Example 1. Synthetic landing page testing. Using AI tools like GPT-4 with DALL-E or Midjourney, you can generate complete landing pages in under 2 hours. The copy, images, and design are all AI generated based on your hypothesis. You input your hypothesis, and AI generates a complete landing page. Headline, value proposition, pricing, call to action. You deploy it using no-code tools and start driving traffic within hours. Example 2. AI customer interviews at scale. This is controversial but highly effective. You can use AI to simulate customer personas and conduct hundreds of interviews to test messaging and positioning. You create detailed customer personas using real demographic data, psychographic profiles, and behavioral patterns from market research. Then you use an AI agent to role-play these personas in structured interviews. In a single day, you can run 100 synthetic interviews, testing different value propositions, pricing models, and feature priorities. This gives you statistically significant signal before talking to real humans. You then validate the top 3 insights from synthetic interviews with 10 real customer calls. This hybrid approach reduces wasted time in real interviews and increases signal quality. Let's move to component 3, the metric. This is your dependent variable, the single number that determines success or failure of your hypothesis. Every weekly test must have one primary metric, not 5 metrics, not a dashboard of 10 KPIs. One metric that matters. Why? Because multiple metrics create ambiguity and prevent clear decision-making. So what should this metric be? The answer depends on your hypothesis and your stage. Let me give you a framework. Match your metric to your hypothesis type. Testing problem existence. Measure survey response rate or engagement with problem description. Testing willingness to pay. Measure pre-order conversion rate. Testing solution fit. Measure feature usage. Testing product market fit. Measure retention rate. Let's work through a concrete example with the code review tool hypothesis we mentioned earlier. Our hypothesis was, remote software engineers aged 25 to 35 will pay $20 per month for an AI code review tool. Our primary metric is landing page to paid waitlist conversion rate. We're not measuring email signups. We're measuring how many people will pay $5 to join a waitlist for early access. This is real money commitment. Why a paid waitlist? Because it's the highest tier of behavioral evidence we can achieve in 7 days without building the actual product. Free email signups are weak signals. Paid commitments are strong signals. Let me show you a back-of-the-envelope calculation to determine sample size and statistical significance. This is where scientific rigor becomes critical. Let's assume our success threshold is 5% conversion from landing page visits to paid waitlist signups. This is based on industry benchmarks for B2B SaaS products. To calculate required sample size, we use the formula n equals z alpha over 2 squared times p times 1 minus p divided by e squared, where z is the z-score for our confidence level, p is expected proportion, and e is margin of error. For 95% confidence, z equals 1.96, expected proportion p equals 0.05, margin of error e equals 0.02 or 2%. Plugging in these values, 1.96 squared times 0.05 times 0.95 divided by 0.02 squared. This gives us 456 required visitors. So we need approximately 450 to 500 targeted visitors to our landing page to achieve statistical significance. This is achievable in 5 days using targeted ads or outreach. Let's do a quick cost analysis. How much will this experiment cost? If we use Google Ads or LinkedIn ads targeting software engineers, Assume $2 cost per click. 500 clicks times $2 equals $1,000 in ad spend. AI tools, including GPT-4 API access and design tools, cost approximately $50 for the week. Landing page hosting on a no-code platform like Webflow or Card costs $30. Total cost per weekly test, $1,080. This is remarkably cheap compared to traditional product development, which costs tens of thousands. Now we reach the most critical component, the pivot rule. This is your decision framework for what to do based on test results. Your pivot rule must be binary, yes or no, continue or pivot, and it must be pre-committed before you run the test. This prevents motivated reasoning and confirmation bias. Here's our pivot rule for the code review tool. If paid waitlist conversion is greater than or equal to 5%, continue to build MVP. If less than 5%, pivot the hypothesis. What does pivot mean? There are 3 types of pivots you can make based on test results. 3 pivot types. Customer pivot. Keep the problem and solution, but target a different customer segment. Problem pivot. Keep the customer and solution approach, but solve a different pain point. Solution pivot. Keep the customer and problem, but change your solution approach. How do you choose which pivot to make? This requires analyzing your test data with AI assistance. Use AI to analyze qualitative feedback from your test. If users said they liked the idea, but the price was too high, that's a solution pivot. If they said they don't have this problem, but mentioned a different pain point, that's a problem pivot. If they said this would work better for a different role, that's a customer pivot. Let me walk you through a real 4-week iteration example, showing how the loop compounds over time. Week 1. We test the AI code review tool for remote engineers aged 25 to 35. Landing page gets 450 visitors, 20 conversions. Conversion rate, 4.4%. This is below our 5% threshold. 4.4% is less than 5%. According to our pivot rule, we must pivot. AI analysis of exit surveys and chat transcripts reveals engineering managers showed higher engagement than individual contributors. They mentioned wanting to reduce their team's review bottlenecks. Week 2, we execute a customer pivot. New hypothesis. Engineering managers aged 30 to 45 at companies with 10-plus engineers will pay $50 per month for an AI code review tool that reduces team review time by 50%. Week 2 results, 480 visitors, 38 paid waitlist conversions. Conversion rate, 7.9%. This exceeds our threshold. 7.9% is greater than 5%. We continue this hypothesis and move to MVP development. Week 3. Now we test pricing sensitivity. We run an A/B test with 3 price points, $30, $50, and $70 per month. Results. $30 per month gets 9.2% conversion. $50 gets 7.9%. $70 gets 4.1%. Revenue optimization calculation. 30 times 0.092 times n is less than 50 times 0.079 times n. The $50 price point generates 31% more revenue despite lower conversion. Week 4. We test the core feature set using an AI-generated interactive prototype. We show potential customers a Figma prototype powered by GPT-4 that simulates the code review experience. We measure feature engagement. Which features do users click on most? How long do they spend in each section? This tells us what to build first in the MVP. Now let's discuss advanced techniques. The weekly loop becomes more powerful when you apply Bayesian updating to your hypothesis confidence over time. Each weekly test updates your prior probability of success. You start with an initial confidence estimate, then update it based on test results using Bayes' theorem. The posterior probability P of H given E equals P of E given H times P of H, divided by P of E, where H is your hypothesis and E is your evidence. Example. After week 1 failure at 4.4%, we update our confidence in the original hypothesis from 50% down to 20%. But our confidence in the customer pivot hypothesis increases based on qualitative signals. After week 2 success at 7.9%, our confidence in the pivoted hypothesis jumps from 40% to 85%. This guides resource allocation decisions. Let's clarify the specific role of AI in the analysis phase. This is where AI provides maximum leverage. First, automated qualitative coding. A. I can analyze hundreds of open-ended survey responses and categorize them into themes. This would take humans days or weeks, but AI does it in minutes. Second, sentiment analysis. A. I can detect subtle sentiment patterns in user feedback that indicate true excitement versus polite interest. Excitement predicts conversion. Politeness does not. Third, competitive intelligence synthesis. A. I can continuously monitor competitor launches, feature updates, and market positioning, then synthesize this into strategic insights for your next hypothesis. Fourth, predictive modeling. After 4 to 8 weeks of tests, A. I can build predictive models of what hypotheses are likely to succeed based on patterns in your data. Let me address common pitfalls in this validation framework and how to avoid them. Pitfall 1. Changing the metric mid-test. This is a cardinal sin. You must commit to your metric before running the test. Changing it after seeing results is p-hacking and leads to false positives. Pitfall 2. Testing multiple hypotheses simultaneously without statistical correction. If you run 5 tests in parallel, your effective p-value changes. Use Bonferroni correction or false discovery rate control. Bonferroni correction. Alpha corrected equals alpha divided by k, where k is number of simultaneous tests. If testing 5 hypotheses with alpha equals 0.05, your threshold for each test becomes 0.01. Pitfall 3. Confusing statistical significance with business significance. A 7% conversion rate might be statistically significant, but if your customer acquisition cost is $100 and lifetime value is $50, the business fails. Pitfall 4. Over-reliance on synthetic data. AI-generated insights must be validated with real customer interactions. Use synthetic testing to narrow the hypothesis space, then validate with real humans. Once you've mastered the weekly loop, you can compress it further. Advanced teams run daily validation loops for rapid iteration. The daily loop tests one micro-hypothesis per day. For example, does changing the headline from faster code reviews to ship code 50% faster improve conversion? This requires automated infrastructure, continuous integration, and continuous deployment for experiments. AI handles experiment design, deployment, analysis, and recommendation without human intervention. Let's look at real-world success metrics from companies using this framework. Case study. A B2B SaaS startup achieved product-market fit in 12 weeks using this framework. They ran 12 weekly experiments, pivoted 7 times, and found their winning hypothesis in week 9. Traditional validation timelines, 6 to 18 months. I accelerated validation, 8 to 16 weeks. This is a 4 to 8 times reduction in time to product-market fit. Let's do a deeper dive into statistical power analysis, which is critical for designing rigorous tests. Statistical power is the probability of detecting a true effect when it actually exists. Standard practice is to aim for 80% power. 1 minus beta equals 0.80, where beta is the type 2 error rate. Power depends on 4 factors: sample size, effect size, significance level alpha, and population variance. To increase power, you can increase sample size, increase effect size through better targeting, decrease alpha tolerance, or decrease measurement variance through better instrumentation. How does this validation loop integrate with actual product development? This is a crucial practical question. Use parallel path architecture. While week 1 tests are running, engineering begins building foundational infrastructure that's hypothesis agnostic. Weeks 1 through 4 run validation experiments while infrastructure is built in parallel. Weeks 5 through 8 build MVP based on validated hypothesis. Week 9 onward is launch and continuous iteration. Critical insight. The validation loop never stops. Even after launch, you continue running weekly experiments on features, pricing, positioning, and new market segments. Let's formalize the economics using expected value of information theory. Each test has a cost C and generates information value I. The test is economically rational if I is greater than C. Expected value of information equals P success times V success minus P failure times C failure, where P is probability, V is value, and C is cost. Example calculation for our code review tool. If we believe there's a 60% chance of success, Success value is $10 million in business value. Failure probability is 40%, and failure cost is $1,080 in wasted test cost. Expected value of information equals 0.6 times 10 million minus 0.4 times 1,080. This equals $5,999,568. Clearly positive, so the test is worth running. Let me give you a practical week-by-week checklist you can use immediately. Monday through Tuesday, use AI to generate and refine your hypothesis. Design your test including landing page copy, target audience, and success metrics. Set up tracking infrastructure. Wednesday through Friday, launch your test. Drive traffic through ads, outreach, or organic channels. Monitor for technical issues but do not change variables mid-test. Saturday through Sunday, analyze results using AI for qualitative coding and pattern recognition. Calculate your primary metric. Apply your pre-committed pivot rule. Document insights and plan next week's hypothesis. For advanced practitioners, consider multi-armed bandit optimization instead of fixed weekly A/B tests. Multi-armed bandit algorithms dynamically allocate more traffic to winning variants during the test. This increases overall conversion while simultaneously testing. Epsilon greedy strategy. With probability 1 minus epsilon, choose the best performing variant. With probability epsilon, choose randomly to explore other options. Thompson sampling is generally more efficient than epsilon greedy. It uses Bayesian updating to balance exploration and exploitation optimally. We must address ethical considerations when using AI for startup validation. First, transparency. When using AI-generated personas for testing, you must validate insights with real humans before making major business decisions. Synthetic data is a compass, not a map. Second, privacy. When collecting user data during tests, comply with GDPR, CCPA, and other regulations. Use AI to anonymize and aggregate data appropriately. Third, avoid manipulation. The goal is to discover true product-market fit, not to trick users into false commitments through dark patterns or misleading messaging. Let me summarize the core framework we've covered today. 1 hypothesis per week. Make it specific, measurable, and falsifiable. Use AI to generate and refine hypotheses based on market data. 1 test designed to reach the highest tier of behavioral evidence possible in 7 days. Aim for actual commitments, not just stated interest. 1 primary metric with a predefined success threshold. Calculate required sample size using proper statistical methods. 1 binary pivot rule committed before the test. Continue or pivot based purely on whether you hit your metric threshold. This framework reduces time to product market fit by 4 to 8 times compared to traditional methods, while also reducing capital requirements and increasing success probability. The real power emerges from the compound effect over time. Each weekly iteration generates learning that feeds into the next hypothesis. Your learning accumulates. L of n equals L0 plus the sum of delta L sub I, where L0 is your initial knowledge, and each test adds incremental learning delta L. By week 12, you have 12 times the market insights of a team that builds first and validates later. This asymmetry is your competitive advantage. Let me leave you with final thoughts on the scientific mindset required for this approach. Embrace falsification over confirmation. Your goal is not to prove your idea is right. Your goal is to rigorously test whether it's wrong before investing significant resources. Detach ego from hypotheses. You are not your idea. Pivoting 7 times in 12 weeks is not failure, it's efficient learning. Trust the process and trust the data. When your pivot rule says pivot, you pivot. No exceptions, no rationalization. Here are your concrete action steps to implement this framework starting tomorrow. Step 1. Identify 1 startup idea you want to validate. Write down the core problem, solution, and target customer. Step 2. Use a large language model to generate 5 specific, testable hypotheses from your idea. Rank them by confidence and feasibility. Step 3. Design a 1-week test for your top hypothesis. Define your metric, sample size, and pivot rule before starting. Step 4. Commit to 12 consecutive weeks of testing. This is your validation sprint. No matter what, you run 1 test per week for 12 weeks. Step 5. Document everything. Keep a structured log of each hypothesis, test design, results, and pivot decisions. This becomes your proprietary dataset, for future AI-assisted optimization. This is how you use AI to validate startup ideas scientifically, rapidly, and rigorously. You now have a complete framework, statistical foundations, practical examples, and action steps. The validation loop is your systematic path from idea to product market fit. Thank you for your attention.